Okay, this is the core 3 homework this week on functions. It's alright, it's not the wrong angle. Shh. Spoiling the video. Right, the functions f and g are defined by... there they are. F of x is x squared, g of x is whatever to x minus 3. State the range of f. So that's the set of outputs of f. Well, f is just x squared for all real values of x. So this is an easy start. But what we've got to remember, of course, is that if you're stating the range of f, you've got to do it in terms of f of x. So f of x is greater than or equal to 0. Notice it's not x is greater than or equal to 0, and it's not pulling faces at me. It's not y is greater than or equal to 0 either. Right, B. The inverse of g is inverse of g. Find that. So we know how we do this. We're going to at some point swap x and y around. Let's start with x is 1 over 2y minus 3. So we're just going to rearrange this. 2y minus 3 is 1 over x. Seems like a sensible first move. Stop moving the camera. And then 2y is 1 over x plus 3. And if we divide by 2, we get 1 over 2x plus 3 over 2. And it's acceptable to leave it like, well, you need to have it as inverse function of g. You could leave it like that. You could, if you wanted to, put it over a common denominator, which would be 2x, and write, it would need to be that, wouldn't it? 1 plus 3x over 2x, but that doesn't matter. I didn't give any extra marks or anything for that. But what you do have to say is when we define a function, we have to say what its domain is. We have to do that as well. So the domain of this is that we can't put x equals 0 into that. So I'm not sure actually in an exam whether you would get 3 full marks for writing that. I decided to be mean when I marked it and give you the final mark for stating the domain. And almost nobody did it. I think one person put what the domain was. Okay? Part 2 says state the range of the inverse. Well, the easiest way of thinking about this is the range of the inverse is the same as the domain of the original function. Because the two things swap round, don't they? So the range of that, we just need to read, this was what the domain was, so it's got to be all real values except 3 over 2. So it was this part 2. Yeah. So all real values except inverse function is not equal to 3 over 2. We can also see it, can't we? The only way that we could that we might end up with 3 over 2 is 3 over 2 from there. It would be this bit, wouldn't it? But if we look at that, the only way you'd get 3 over 2 is if this bit was equal to 0, and this bit can't be equal to 0 because it's 1 over 2x. And so you can get it from there as well. Part C said, solve the equation f of g of x equals 9. And this was just about understanding the way the composite functions are put together. So this is f of g of x is equal to 9. And the function f says that you square whatever the input is. So this is 1 over 2x minus 3 all squared. It's 9. We're now going to think how we're going to deal with this. Well, we're going to have to try and get x equals, we're going to take square root of both sides. So 1 over 2x minus 3 is plus or minus the square root of 9. And loads of people went wrong by missing out the plus or minus at that point. Now we need to work out how to get x. If we take the reciprocal of both sides, we've got 2x minus 3 plus or minus a third. So 2x is 3 plus or minus a third. At which point it might be sensible to say that that is 2x is, that was a third supposed to be there. 2x is 3 and a third, or 10 over 3. And and 2x is 8 over 3, which is 3 minus a third. And if we divide through by the 2, that gives us x is 5 over 3 and 4 over 3 as our solutions to that equation. That seemed like quite a stingy 3 marks to get to the 2 solutions at the end of it. Loads of people went wrong with the plus or minus. Second question was a bit of a monster, really. This is, again, a genuine Core 3 plus paper question for 8 marks. This is exactly as it appeared on the paper. The equation is y equals x squared ln 4x minus 3. Find the exact value of dy by dt by dx squared at the point for which x equals 2. The only blessing in this is that they don't want us to do that awkward thing where we have to combine things together and simplify it, because all we have to do at the end is sub 2 into it. So dy by dx, to begin with, we've got a product rule, haven't we? We've got x squared times the natural log of 4x minus 3. So that's the first times the derivative of the second. And if you differentiate the natural log of 4x minus 3, that's big bear, little bear thing, isn't it? It's the big bear is natural log of something. So it's 1 over the something times the derivative of the inside, which is 4, plus the second times the derivative of the first, which is 2x. So, we've got dy by dx. The main thing about this is this now, we have to differentiate it again. And as we're going to differentiate it again, we now have 2 things to differentiate. We have a quotient and a product. So we're going to go through all that again, but we're going to do both all in one go. So the quotient, we've got u over v, and so, which comes first, u dv by dx or v du by dx when you do the quotient rule? Good, you can think visual display unit, v du by dx. That's a brilliant way of remembering it, isn't it?
Yeah.
Yeah, thanks. There, you heard somebody say yes there. So if we work this through, this is v times du by dx minus u times dv by dx, which would be 4, all over v squared. And then we've got the product to deal with, which is the first times the derivative of the second, plus the second times the derivative of the first. And we get all of that, which we can tidy up slightly, although it's not that big a deal. Do we want to tidy it up?
No.
I'm not even sure I do. All that matters is we want to know what this is when x is 2. So let's put x equals 2 into this straight away. I think I actually did tidy it up a little bit more, but it's not a great hassle to do as it is. What we've got there, so we've got 5 times 16 minus some stuff. (256). No, it's not at all, is it?
No.
Oh, I don't know. Just plucked a number out of thin air. That's 4, isn't it? Times 4 is 16, times 4 is 64. Let's go with that.
What did you do?
We'll go with that.
16 times.
Yeah. I squared 2 and got 16. Right. Put 2 into this one as well. We've got 8. No, we haven't. Thanks. We've got 16 over 5 there, and here we've got 2 over 5. Is that a bit right? Is that sarcastic agreement then? Collect things together, tidy it up, we end up with 96 over 25 out of these bits. And 2 ln 5. The question did say, didn't it, give an exact value? The exact value. So there it is. Right, yes. Okay.
I think I deserved a mark,
Okay.
actually. Yeah.
When only 5 of you clap, it just sounds sarcastic.